Hi everyone, today we're going to look into the concept of having polar bonds but non-polar molecules. Now, this kind of goes under the theme of having polar covalent bonds, and it may kind of seem to contradict what we've learned earlier regarding how difference in electronegativity values immediately correlates to a polar molecule, but then this is something else. And we are going to look at this via an example of CF4. Now, in CF4, carbon is going to have an electronegativity value of 2.6, and fluorine is going to have an EN value of 4.0. Now, upon what we have defined earlier in some of our earlier videos, a value of EN difference between 0.5 and 1.8 is qualified as a polar molecule or a polar bond. And based on what we can calculate as the value of difference between carbon and fluorine, we can calculate that the difference in EN value for these two atoms is going to be 1.4, which is clearly within the threshold between 0.5 and 1.8. Thus, from this, we can conclude that the CF bond is indeed a polar bond. Now, would this make the molecule of CF4 a polar molecule, though? Well, upon what we've learned, kind of just judging only singularly based on this criteria, we may be able to conclude that it's a polar molecule. But we have something that's called symmetry in a molecule. And because the center of positivity and the center of negatives both kind of lie on the same point in the CF4 molecule, we can conclude that the molecule itself is going to be symmetrical, and thus we can conclude that it's not a polar molecule. Now, I'll show you what that means. When we draw out the CF4 molecule, it's going to look like this, which is in the form of a tetrahedral molecule. And we've learned that the EN value of F is going to be greater than the EN value of carbon, which means that the electrons would be closer to fluorine rather than carbon, and therefore fluorine is going to have a slightly negative charge, whilst carbon is going to have a slightly positive charge. And by the way, the delta means small change or slight change, and therefore these are the notations. And based on this, we can conclude that the center of positivity, because it's generally represented by carbon in this sort of formula or in this sort of molecular geometry, we can conclude that the center of positivity is going to lie on the carbon. Now, where would the center of negativity lie? Where would the center of negative lie? Well, it's also going to lie on carbon and on the exact same position as the center of positive. And that's because we know that each of these bonds are same single bonds between the same two molecules, between the two same atoms that come from the same element. Therefore, we can conclude that the center of negative is also going to lie on the same point as the center of positive. So, because the center of negative and the center of positive overlap, we can conclude that the molecule is symmetrical. And therefore, the dipole cancels out, i.e., we're not going to have any net dipole moment. And because we do not have any net dipole moment, the entire molecule is going to be nonpolar. Now, this is again one of the two criteria as to how to kind of qualify or kind of classify a certain molecule as polar. The other one, besides judging the center of positive or negative, is also looking at the vectors. And what do I mean by looking at the vectors? Well, we know that we represent a vector in a certain molecule that has certain small charges in a polar bond by representing a vector line that goes from the positive charge towards the delta negative charge. And so we are going to draw vectors like this. And again, we kind of see that the vectors just cancel themselves out, and again re-verify the point that we have no dipole moment, because all of these CF bonds are composed of the same atom, of the atoms that come from same elements, and also they're all single bonds. So therefore it means that in this tetrahedral molecular shape, the center and the center of positive and the center of negative is also going to overlap, and the vectors kind of cancel out. So based on this criteria, when we look at the center of overlap and the vectors and calculate like whether it results in a significant change or not, we can, based on this criteria, conclude that although the bonds are polar, the molecule itself is nonpolar.